For centuries, humanity has feared one thing above all in the sky: the sun, a blazing star, a furnace of nuclear fire, a place where temperatures reach millions of degrees. Too hot to touch, too dangerous to approach. For thousands of years, the lesson was simple. Some places in the universe are not meant to be reached. But scientists kept asking a question. What if we could go there? What if we could send a machine into the sun's outer atmosphere, into the corona, the hottest and most violent region of our star, a place where temperatures exceed 1 million degrees Celsius, nearly 2 million degrees Fahrenheit, a place no spacecraft had ever survived, until one mission dared to try. A spacecraft designed to dive toward the star itself. Its name, Parker Solar Probe. A mission not just to observe the sun, but to touch it, and to uncover the secrets hidden inside its blazing atmosphere. But before this spacecraft could dive into the fire, scientists first had to answer a difficult question. Why attempt such a dangerous mission at all? The mission behind Parker Solar Probe was not created overnight. For decades, scientists wanted to understand the sun more closely. Why is the solar corona hotter than the sun's surface? How does the solar wind accelerate through space? And why do violent solar storms sometimes strike Earth? These questions became increasingly important because solar storms can damage satellites, disrupt communications, and even shut down electrical grids. To answer them, the NASA approved an ambitious mission, a spacecraft that would travel closer to the sun than any probe before it. The project took years of research, engineering, and testing. The total mission cost was about $1.5 billion, a price for unlocking the secrets of our star. 6 weeks after its launch, the Solar Observer passed by Venus, using the planet's gravity for a crucial maneuver, not to speed up immediately, but to fall closer to the sun. With each flyby of Venus, the spacecraft lost orbital energy and gained something far more powerful: velocity toward the sun, like a stone falling deeper into a gravitational well. Faster and faster. So going to the sun is actually harder than leaving the solar system. That's why Parker Solar Probe doesn't try to go straight. Instead, it uses a clever strategy. Gravity assists, but not to speed up, to slow down. Over several years, the spacecraft flies past Venus, again and again. Each time, the planet steals a little of its sideways speed, not accelerating it, but pulling it inward, closer to the sun. By November 21st, 2021, Parker became the fastest human-made object in history, reaching about 586,000 kilometers per hour, almost 10 times faster than the Voyager probes. It could circle the Earth in less than 4 minutes. On October 29, 2018, around 1804 UTC, the spacecraft became the closest artificial object ever to the sun. The previous record, held by Helios 2 in April 1976, stood at 42.73 million kilometers from the sun's surface. On September 27, 2023, Parker approached even closer, 7.26 million kilometers, for about 4.51 million miles, reaching this distance again on March 29, 2024. On December 24, 2024, at 11:53 UTC, the probe performed its closest approach yet, just 6.1 million kilometers, for about 3.8 million miles from the surface of our star, a historic record. At that distance, The spacecraft was about 7.5 times closer to the Sun than Mercury, the closest planet to the Sun, and 24 times closer than Earth. The probe faced extreme conditions. Solar energy levels 500 to 600 times stronger than on Earth, a heat capable of melting metal in mere seconds. And yet, Parker survives. Thanks to its thermal shield, with each orbit it plunges again, closer, faster, hotter. A machine built by humanity, now diving deeper into the fire than anything before it. So why doesn't it melt? To face the Sun, you don't just need courage, you need protection. At the front of the spacecraft, a white heat shield stands like a barrier between the machine and a star. Built from advanced carbon materials, hardened under extreme temperatures, this shield is both incredibly strong and surprisingly light. Inside it, a carbon foam structure, made of nearly 97% air, absorbs and blocks the Sun's fury, keeping the instruments hidden behind it in near-room temperature conditions. But surviving the Sun is not just about resistance, it's about precision. The spacecraft must constantly adjust itself, keeping the shield perfectly aligned with the Sun at all times. If it drifts, even slightly, it corrects itself instantly, automatically, because no human could react fast enough from millions of kilometers away. And while the front burns, the rest of the spacecraft stays cool. Water flows through hidden systems, circulating behind the solar panels, carrying heat away, like blood flowing through veins, warming, then cooling, again and again. And so, protected by science, guided by precision, and designed to endure the impossible, Parker Solar Probe does the unthinkable. It doesn't avoid the Sun, it survives it. But speed and heat are not the only dangers. There is something else, invisible, constant, violent: the solar wind. A constant stream of charged particles, hydrogen, helium, fragments of a star escaping into space. This is no ordinary wind. It moves at speeds of up to 1.4 million kilometers per hour, faster than anything we experience on Earth. And it never stops. It flows outward, across the entire solar system, until it reaches the very edge of the Sun's influence. And sometimes, it reaches us. When it collides with Earth's magnetic field, it shakes our invisible shield, disturbs it, energizes it, and the sky responds with light, auroras, dancing across the poles. Beautiful, but born from a violent interaction. Yet the solar wind is not always harmless. Stronger bursts can disrupt satellites, damage electronics, interfere with communication systems, even affect power grids here on Earth. Because when the Sun erupts, we feel it. As scientists say, if the Sun sneezes, Earth catches a cold. And this is why Parker Solar Probe exists: to enter the corona, to fly through the solar wind, to measure it from the inside, closer than any spacecraft in history, because only there can we finally understand how a star works and how to protect ourselves from its power.